Welcome to the jet age. The introduction of commercial jet aircraft during the 1950s represented much more than simply an improvement in aircraft performance. By this point, piston-powered airliners had reached practical limitations in speed, complexity, capacity, and productivity. Jet propulsion dramatically changed those limitations by allowing aircraft to fly faster, higher, farther, and with substantially greater passenger capacity. The central question of this research is therefore not simply how jets changed airplanes, but how they transformed the larger commercial aviation system. My research examines the effects of jet technology on airline economics and operations, airport infrastructure, and aviation safety management. The central argument is that these changes were interconnected. Once aircraft capabilities changed, airlines, airports, regulators, air traffic control, and safety organizations all had to adapt. In that sense, the jet age was a system transformation, not merely a speed revolution. This graphic illustrates the fundamental technological transition that began the jet age. On the left is the mature piston airliner era, represented by aircraft that were technologically sophisticated, but increasingly constrained by speed, capacity, operating costs, and productivity. On the right, early commercial jets dramatically expanded what airlines could accomplish. The most obvious improvement was speed, but the consequences went considerably further. Greater range made more nonstop routes practical. Increased capacity changed the economics of individual flights, while shorter flight times allowed airliners to obtain greater daily utilization from extremely expensive aircraft. What began as a propulsion breakthrough therefore produced effects throughout commercial aviation. Airlines could redesign networks and schedules, airports had to accommodate larger and faster aircraft, and regulators and safety organizations confronted operating conditions that previous systems had not been designed to handle. That progression from technological breakthrough to system-wide change is the foundation of this research. This comparison puts some numbers behind the transformation. Representative late-generation piston transports typically cruised at approximately 330 to 360 miles an hour. Early jet transports approached 600 miles per hour. On a route such as New York to Los Angeles, that difference reduced typical block time from approximately 8 or 9 hours to around 5. Passenger capacity also increased substantially. Aircraft such as the DC-7 and Super Constellation commonly carried roughly 60 to 95 passengers, while early Boeing 707 and Douglas DC-8 configurations could accommodate substantially more. The improvements affected the airline economics as much as passenger convenience. Faster aircraft could complete more productive flying within a given period, while greater capacity distributed operating costs across more passengers. The combination of speed, capacity, range, and utilization fundamentally changed the airline productivity and helped make the emerging jet transport economically transformative. This graphic expands the analysis beyond aircraft performance and shows the jet age as an interconnected system. I divide the transformation into 4 major areas: airline operations and economics, airport infrastructure, safety and regulation, and passengers and global connectivity. These areas did not develop independently. Longer range aircraft changed airline route structures and scheduling. Those changes increased demands on airports, requiring stronger runways, larger terminals, expanded aprons and gates, and increasingly sophisticated air traffic control and ground support systems. At the same time, higher speeds, greater traffic density, and new aircraft technologies created new safety challenges. Regulators, manufacturers, airlines, and air traffic organizations consequently had to develop stronger certification standards, training programs, maintenance practices, and oversight systems. Finally, passengers experienced the combined result. Air traffic travel became faster, increasingly accessible, and capable of connecting cities and economies on a scale that had previously been impractical. Jet technology was the catalyst, but system integration created the modern airline industry. The operational consequences of jet technology were substantial. Airlines redesigned schedules, maintenance programs, crew training, fleet utilization, route structures, and long-term capital planning around aircraft capable of traveling much farther and faster. Excuse me. Shorter block times and longer range supported nonstop service, international network expansion, and much greater aircraft productivity. Airports faced an equally significant transition. Jet transports required longer and stronger runways, larger terminal facilities, expanded gates and aprons, more sophisticated ground support, and increasingly capable air traffic control systems. Chicago provides a useful example. Midway Airport had been one of the country's most important commercial airports during the piston-era, but its physical limitations made accommodating the emerging jet fleet increasingly difficult. More scheduled operations consequently shifted toward the more expandable O'Hare Airport. This demonstrates an important point. The aircraft did not simply adapt to the existing aviation system. In many cases, the aviation system itself had to be rebuilt around the capabilities and requirements of jet transportation. This graphic brings those individual changes together. The central idea is that technological capability alone does not create a successful transportation system. The aircraft may provide the speed, range, and capability, but realizing those benefits require infrastructure, regulation, organizational capability, and people to evolve alongside the technology. That relationship is particularly important from a safety perspective. As commercial aviation became faster and more complex, safety could no longer be understood primarily as a property of the aircraft itself. It increasingly depended upon interactions among aircraft design maintenance, flight crews, air traffic control, airports, regulators, and airline management. The modern aviation system that emerged from the jet age was therefore socio-technical in nature. Its performance and its safety depended upon all of these elements functioning together. That may be the most important legacy of the jet age. It demonstrated that advances in aviation technology ultimately require corresponding advances throughout the system supporting that technology. The safety history of the early jet age demonstrates why this system-wide adoption was necessary. The de Havilland Comet failures exposed serious concerns involving metal fatigue and repeated pressurization cycles. The lessons from those fatal accidents contributed to stronger structural testing, inspection practices, and certification requirements. At approximately the same period, the 1956 Grand Canyon mid-air collision demonstrated another problem. Aircraft capabilities and traffic growth were advancing faster than existing American air traffic control system. The accident became an important catalyst for modernization of air traffic management and federal aviation oversight. Together, these examples demonstrate that the jet age required more than technological advanced aircraft. It required aviation safety to become increasingly proactive, integrated, and system-oriented. The lasting significance of the jet age, therefore, was not simply that airplanes become faster. Jet technology transformed airline economics, airports, regulation, air traffic control, and global connectivity. The central conclusion of this research is that technological capability and system safety had to evolve together, and that principle continues to define modern commercial aviation. Thank you for watching. I do appreciate the time and consideration, and I do hope this presentation provided a meaningful perspective on how the jet age transformed commercial aviation and helped shape the modern airline industry. Have a great day.